Minterms. If we have two logic variables, x and y, then there are four possible combinations with the AND operation, namely x bar y bar, x bar y, x y bar, x y. Each of these product terms is called a minterm. So a minterm is a product term, but it contains all the literals in one way or another, whether it's complemented or uncomplemented. A minterm of two variables is the product of two literals from the different variables. A minterm of n variables is the product of n literals from the different variables. Okay, what is a maxterm? A maxterm is a sum term. For example, if we have the same example before, if we have two variables, then we can have x bar or y bar as a sum term, x bar or y as a second sum term, x or y bar, this is a third sum term, and finally x or y. So we can have four sum terms. Each of these sum terms is called a max term. It is called a max term. So a max term is a sum term that contains all the variables in the expression. Comparison between minterms and max terms. As we said, x and y are the two variables. These are the different combinations that the variables have. Okay, the first product term is x bar, y bar, and this is called minterm 0, and it is noted as m0, small m0. And as a max term, this is x or y as a max term. This is a sum term that is a max term, and it is noted as capital M0. So the minterms and max terms of two variables are denoted as M0 to M3, these ones here. And the max terms are capital M0 to M3, which are these. Example, the minterm M2 is equal to x, y bar. Okay, the complement of M2, which is this, is equal to the complement of this, which is here. Using De Morgan's theorem, then this is equal to x bar or y. And this actually is this part, which is the max term M2. So the minterms and the max terms are the complement of each other. M2 as a max term is the complement of M2 as a minterm. Okay, we can express the functions as sum of minterms. Let's take a look at this function. F1 is equal to x, y, z bar. Notice these here, x, y, and z. These are called the domain of the function f1. So the domain of this function is x, y, z. Notice that this term is a minterm because it contains all the domain variables. And this minterm is minterm number 6. So f1 is equal to m6. We can note it as f1 equal to m6. f2 has the domain x, y, z, and this is the product term, which is a minterm because it has all the variables in it, and this minterm is minterm 1. and this here is minterm number 4, and this here is minterm number 5. This is minterm number 6. Where did I get this 6 from? It's 1 for x, 1 for y, 0 for z. All right, and this is minterm number 7. So we can express F2 as the sum of minterms M1 or M4, M5, M6, M7, and we can write it this way: the sum of 1, 4, 5, 6, and 7. Same thing for F3. This is the minterm number 1, z being equal to 1. This is 0, this is 0, so that makes this one the minterm number 1. This is minterm number 3, 1, 1, 0. That's 3. Here it's 4, 1, 0, 0. And this is minterm number 5. So this is equal to minterm 1, 3, 4, and 5 as sums. We can express it this way with the sum notation. Okay, let's take a look at these functions in the truth table. F1 has the domain x, y, and z, so these are the inputs, which are the domain of the functions. F1 is equal to M6. Where's M6? This is M6. 1, 1, 1. So we put a 1 here. And all the other minterms are 0. F2 is minterm 1, 4, 5, 6, and 7. F2 is minterm 1, 4, 5, 6, and 7. F3 is minterm 1, 3, 4, and 5. 1, 3, 4, and 5. Okay, convert to standard sum of products using the truth table. This is the function F1. We want to convert it into the standard sum of product, or what we say canonical form. Canonical form is where we put the function as sum of minterms. F1 is equal to M6, as we said before. This is F1. It's equal to 1 when x to 1, y1, z 0, which is this. And all other values for F1 are zeros. Okay, F2 is equal to x or y bar z. Where's F2 equal to 1? When x equal to 1. Where's x equal to 1? All these places here. And where y equal to 0, z equal to 1. Y equal to 0, z equal to 1. Y equal to 0, z equal to 1, which is already here. The rest of the values for F2 are zeros. F3 is equal to 1 when x to 0, y to 0, z to 1. And that's F3. And when x to 0, y to 1, z to 1, and x to 1, y equal to 0. And the rest of F3 values here are zeros. Now we find F4, x equals 1, y equals 0. X equals 0, z equal to 1. So F2, for example, is the sum of minterms 1, 4, 5, 6, and 7. F4 can put it as the sum of minterms 1, 3, 4, 5. Max terms are sum terms. The max terms for the function are the terms for which the function is equal to 0. Boolean functions can be expressed as product of max terms. Convert the following function to product of max terms. This is put in sum of product, canonical sum of product. sum of minterms. F2 is equal to the sum of minterms 1, 4, 5, 6, and 7. Okay, if we put F2 in a truth table, these are the minterms 1, 4, 5, 6, and 7. If we take the complement for this function, we convert the 1 to a 0, we convert the 0 to a 1, and so on. So this is F2 complement. If we put F2 prime as a sum of minterms, it's equal to M0, M2, M3. Okay, if we take the complement of the complement of the complement F2 is equal to F2. And this is complemented. Apply De Morgan's theorem here. So this is M0 complement ended with M2 complement ended with M3 complement. And we know that the complement of the minterm is the max term. So this is equal to M0 capital, M2 capital, M3 capital. So we converted this from the sum of minterms into the product of max terms. These are the same functions. This is F2 expressed as product of max terms, and this is F2 expressed as the sum of minterms. And we can denote this as the product phi of the max terms M0, M2, M3. Notice that this is where the function is equal to 0. This is max term M0. This is max term M2. And this is max term M3. Okay, convert to standard product of sum using algebraic manipulation. Given that the function is given as the domain of F3, I should have given you this, is x, y, z. This sum is missing the y literal. This sum here is missing the z literal. I should note here that y ended with y bar is equal to 0. X ended with x bar is equal to 0. Z is ended with z bar is equal to 0. So we can have F3 put this way. F3 is equal to this, ORed with 0, which is this, the missing literals. And this one is here, ORed with z dot z bar, which is 0. Now we use the distribution law. We distribute this over the and this is equal to x or z or y, which is this, ended with x or z or y bar, which is this. The same thing goes here, x or y bar. This is x or y bar, or with z, and the next time it's ORed with z bar here. And you notice that this is a sum term that is a max term because it contains all the variables in the domain of the function f3. This is a max term. This max term is M0. This max term is M2. Why is it M2? Remember the order x, y, z. Y is equal to 1. So the complement of this one is 0. It's 0, 1, 0, which is M2. The same thing goes here. This should be in the same order like this. So these two are the max terms M2. And we know that M2 ended with M2 is equal to M2. And the last max term here is M3. So this function is equal to the product of max terms M0, M2, and M3. So we put this function in the canonical form. Okay, try to get the same answer using the truth table. Of course we can. Let's have the three variables, and this is f3 here. It is equal to 0 when this one is equal to 0, or this one is equal to 0, which are here. So f3 is equal to the max terms m0, m2, and m3. And the complement of f3 is the minterm, this one, this one, this one, minterm m0, m2, m3. Let's use algebraic manipulation to convert this function into the standard sum of product. Okay, we should note that x or x bar is equal to 1. This function here, f2, is equal to this. It is x ended with 1. This is 1, which is y or y1. Why did I choose y or y1? This term here is missing the y variable and is missing the z variable. This term here is missing the x variable. So this is the same as this, ended with 1. This is 1, which is the missing literal. Okay? So we distribute this and we get xy, which is this, ORed with xy bar, or y bar z ended with x, y bar z ended with x bar. Okay, now this term is missing the z literal, and this one is missing the z literal. We can introduce this by ending with 1. This is a 1. xy ended with z or z bar, and xy bar, which is this, ended with z or z bar. And this is not missing anything, so we leave it as it is. This is not missing anything, we leave it as it is. We make use of the distribution theorem. xyz is this or is this, xyz bar, xy bar z, and xy bar z bar, which is this. And this is the same. Now you see this term is a minterm, and this is a minterm, and this is a minterm. All of these are minterms. And actually this is minterm 7, minterm 6, minterm 5, minterm 4, and minterm 1, because this is also minterm 1. So minterm 1 is included once because it takes care of these two minterms. This is minterm 1 and this is minterm. Conversion between canonical forms. If we are given a function in sum of minterms and we want to convert it into product of max terms, f1 is equal to the sum of minterms 3, 4, 5, 6, and 7. This is equal to the max terms 0, 1, and 2. What's missing here is 0, 1, and 2. We know that the max term is where the function is equal to 0. Of course, this function is equal to 0 for the max terms 0, and 1, and 2. Now, given this function as max terms 0, 3, 5, and 6, convert it to minterms. Minterms are the complements of the max term. So this is equal to the sum of the complements. What is the complement here? It's the missing terms, which is 1, 2, 4, and 7. Okay, if we have this as sum of minterms and we want to find the complement of it as sum of minterms, okay, it is 0, 1, and 2. The complement of this one is minterms 0, 1, and 2. If we are given this as max terms 0, 1, and 2. When we want the complement as max terms, it is 3, 4, 5, 6, and 7. And if we have these are the minterms, we want the complement of this function as product of sums. The product of sums are the same for the complement. Remember, this is for the complement of the function. If we have this as a product of sums 0, 1, and 2, and we want the complement as minterms, it is the same. The complement of the minterms is the same. So this is F1 and F1 complement. This is in max term, and this is in sum of minterms.